Alright guys, so today we are going to start with section 4.1, example 2. I'm coming down with a little bit of a cold, so my voice and my throat's a little shot. Um, my voice and my throat are a little shot, so I'm gonna sound a little funny and different, but not that, not that I sound, you know, not funny every day. I think I'm pretty goofy and weird most days. With that said, let's start example 2. State the transformations and graph. Okay, so we are going to graph each one in stages, just like we have been doing all year long. Okay, so the first one we are going to start is just the parent function. So the parent function, let me just get a pen so it's darker. A parent function is pretty much without any transformation. So right here you have f of x equals, and then x minus 2. This is a right by 2 units, and then to the 5th power. So you're going to start with f of x. Oh man, is this pen not working? Alright. Sorry. I'm going to be making a lot of clear and throat noises during this video. I'm just looking for a darker color pen, or a pen actually. Not, I don't care. A pen that works. So give me a second. Oh my goodness. Okay. Doesn't look like I'm very successful in locating a pen. That works. Alright. Nope. Alright, a pencil. It will do. Oh, here. A red pen. Okay. So a parent function is going to be f of x equals. We're going to keep the exponents. Okay, so x to the 5th. So what we're going to do is we're going to use minimum 3 points. And so here we go. When x is 0, okay, 0 to the 5th is still 0. When x is 1, 1 to the 5th is 1. When x is negative 1, negative 1 to the 5th is going to be negative 1. So with those 3 points, we're going to plot them. So 0, 0, okay, 1, 1, negative 1, negative 1. Now keep in mind this is an exponential equation, okay, and it looks like y equals x to the 3rd. And you're right, it does, okay? It does look like y equals x to the 3rd, and it's going to look like y equals x to the 5th. So all odd exponential functions will look the same, okay? I'm sorry, this is not exponential. All odd power function looks the same. This is not an exponential. I'm really sorry. Okay, so we only have one transformation, so we're going to write the equation y equals x minus 2 to the 5th, okay? I'm sorry. Let me get some water. So this is transformation to the right by 2 units. Okay. Right by 2 units, that means my x's will change. So what I'm going to do is I'm going to take all my x's and add 2. See that right there? The y values, all the y values will stay exactly the same. So pretty much this is my formula for my new 3 points. So here's my x. X plus 2 is going to be 2. Y will stay the same. And then 1 plus 2 is going to be 3. Y will stay the same. Negative 1 plus 2 is going to be positive 1. Y will be staying the same. Okay? So now we're going to start at 2 comma 0, 3 comma 1, and positive 1 go to negative 1. The curvature of your graph, the shape of your graph, should always be the same. You're just picking it up and you're moving it, so therefore it shouldn't look any different, okay? Okay. It doesn't say find the domain and range, but I always ask for those anyway, so I might as well just find these. The domain is negative infinity to infinity, or aka all reals. The range is also all real, okay? You can write all reals if you want to, but because we're kind of going with the new notation of the interval notation, so we are going to practice that as well. And keep in mind that I'm always going to give you more coordinates than you need, that doesn't mean you need to use all of them. Okay, you can use all of them if they fit, but you don't have to. All right, so let's go to example B. Y equals f of x equals quantity of x plus 2 to the fourth power minus 3. So again, we are going to start with the parent function. Okay, the parent function meaning that I'm going to strip of everything except x. So f of x equals x and then the power. So each parent function is going to have a different power. It's not always just x, okay? If you're giving me the parent function is f of x equals x, that is completely wrong. This function has a power of 4, so we know it's an even function. An even function, all even functions will look exactly the same, okay? So let's start with the 3 points. When x is 0, y would be 0. When x is 1, 1 to the fourth would be 1. When x is negative 1, negative 1 to any even power would be positive. So this is the only thing that's different from odd function, okay? This negative x right here resulted in a positive x because of an even function. In the odd power functions, negative x will still have a negative output. So we are going to start with 0, 0, positive 1, comma 1, and negative 1, comma positive 1. All even functions will look like a parabolic shape or parabola. Okay? So make sure you don't make it like a V. I will take points off if it looks like a V, so please round it out at the bottom. So our next equation is going to be f of x equals x plus 2 to the fourth. Okay. So it says here we need to state the transformations. This is right by 2. Right by 2. I'm sorry, not right. This is left. Let me get my white out. This is left by 2. So as I'm waiting for that to dry, left by 2 meaning that I'm going to take all my x values and subtract it by 2. So the equation for it would be x minus 2. It's not going to change my y, so I'm just going to keep y the way it is. Okay, so this would be my order pair for all of these points here. So I'm still waiting for that to dry. We'll fill that in just a second. Let's work with the points. 0 minus 2 is going to be negative 2. Y will stay the same. 1 minus 2 is going to be negative 1. Y will stay the same. Negative 1 minus 2 is going to be negative 3. Y will stay the same. Okay, so let's fill this in. Left. Left by 2. Oh, I meant y would they say? Y is going to stay the same at 1. There you go. So here we go. Negative 2, comma 0. Negative 1, go up positive 1. Negative 3, positive 1. So notice how the shape of it is still parabolic or parabola. Okay, you're just moving it from the center. That's all that is. Okay, so the vertex instead of at the origin, it's now to the left. We have one more transformation for part B, which is the last one. F of x equals, we did this piece already, right? Sorry, this is to power 4. Okay, now we're just going to move over and do the minus 3. This is a down by 3 units. Down by 3. What that is going to do is now I'm going to take all my y's and I'm going to subtract 3. So the x minus 2, it's already there, okay, from this piece. So I'm just going to copy that over. So x minus 2, you did this already. You don't have to do it again, okay? But now we're just going to go and take the y and then subtract 2. And we're always going to do this from the parent function, okay? So here we go. We did the x already, so let's write our 3 points down. The x minus 2, that transformation is already done, so let's just copy the x's over. X, x, and x. Okay, those are done. Now let's take care of the y. Excuse me. So here we go. 0 minus 3 is going to be negative 3. 1 minus 3 is going to be negative 2. Positive 1 minus 3 again, is negative 2. So these are our new points here. So negative 2, go down to negative 3. That's my first point. Negative 1, go to negative 2, my second point. My third point is negative 3, 1, 2, 3, go to negative 2. Okay, again, the curvature should not change. Location of the vertex did. It moved, okay? But that doesn't mean the way that it shouldn't look different from your parent, okay? So this is the 3 different graphs with 2 different transformation and the parent function. Take a minute to finish copying, and then we're going to go to example 3. Okay, so now we are going to do example 3. Example 3, form a polynomial. They are giving you the zeros are negative 2, 2, and 3, and you have a degree of 3. A degree of 3 meaning this is my highest exponent, okay? We are going to start out with f of x equals. Because it says a degree of 3, we're going to have 3 different parentheses. Ready? 1, 2, and 3. Okay. With degree of 3, have 3 different parentheses. If degrees is 4, then we have 4 sets of different parentheses. So just check out the degree first, and that's how many sets you're going to have. Then we're going to go in and we're going to write down the factors. We're always going to start with the x. We're trying to write an equation, meaning that we're going to have to distribute these things out. So it's going to do x minus on all of these. Okay, we're going to start x minus on all of these. And then the zeros, we're going to fill those in. We have the first zero is negative 2, the second zero is being positive 2, and the third zero is being positive 3. So now with a negative and a negative, that will make it a positive. So let's just write that over. Or you can just simply change that to a positive if you wish. Okay. Alright, so now let's distribute. These two are conjugates of each other. So what we're going to do is conjugates are nice and easy to multiply. We just have to multiply the first 2 and the last 2. And bring down the x minus 3 because we need to distribute that as well. So let's multiply x squared times x. Here we go. X squared times x is going to be x to the third. X squared times negative 3 is going to be negative 3x squared. Negative 4 times x is going to be negative 4x. Negative 4 times negative 3 is going to be positive 12. So this is my polynomial with the degree of 3. Because it has 3 zeros, that means it has 3 factors. Okay, so we write the factors in this form and then going backwards. So pretty much you're going backwards. If I were to factor this out, I would get these answers. Okay, so let me tell you why we started with the parentheses and the x minus. So let's just say that I said factor these, okay? Factor. To factor 4 terms, you would do, let me just copy it over so I don't mess up my writing. To factor 4 terms, you would factor by grouping, okay? These 2 pieces, I'm grouping them together, and these 2 pieces, I'm grouping them together. These 2 have in common is x squared, okay? That's what they have in common. So now I'm putting out x squared. I'm sorry, this is supposed to be x to the third. I'm putting x squared from x to the third, I still have an x. I'm factoring out x squared from negative 3x squared, I have negative 3. Over here, these two have negative 4 in common. Excuse me. Sorry, that was a bad cough. I just want to cover the microphone so it doesn't get too loud in your ears. So this one I'm pulling negative 4 out from negative 4x. I'm ending up with a positive x. Pulling negative 4 from a positive 12, so I'm ending up with a negative 3. Notice how they both have these these two are the same, so you can factor it out. So now you just have two terms. You went from 4 terms to 2 terms. And these two terms have x minus 3 in common. So you can pull that out, x minus 3. So now you have another factor left, x squared minus 4. Okay? This is what we have. Well, this one you can't factor any further, but this one you can. So x minus 3, bring it over. X squared minus 4, these are the difference of two squares, so you can factor that by doing x plus 2 times x minus 2. So notice how if I were to check my answer and factor it, these is the same as that. Okay? So if I were to solve them, I would take each one and set it equal to 0, and that means I'm ending up with positive 3, which match, and a negative 2, which we have here in the original problem, and a positive 2, which we have here in the original problem. So to go backwards, you would start with the factors. Okay? Alright, so let's go on and do this one. They're giving you zeros, negative 2, with the multiplicity of 2. Okay? This means I have 2 of these. I'm just repeating myself. That's all that is. And a 0, 4 with multiplicity of 1. That means I only have 1, so I'm not repeating myself here, with the degree of 3. And again, if you have a degree of 3, then go ahead and make 3 sets of parentheses. Okay? And then we're going to start with an x minus, always. Okay? Just like over here. See, x minus, and then we had a 0 of 3, we put in 3. X minus, we had a 0 of 2, so we put in 2. And then with x minus, a negative 2, and then it changes to positive 2. So in essence, we're just going backwards, okay? So we have a negative 2, put in negative 2. But negative 2 multiplicity of 2, meaning that I have it twice. Okay, that's what it means. And the next one is, my next 0 is 4, so put it right there. So because this is going to change it to positive, so let's do x plus 2. And you can do this from very first step. I'm just, because I'm lecturing and not all of us are at the same level, so I'm just going to show you all the steps, okay? So from here, let's distribute. X times x is going to be x squared. X times 2 is going to be 2x. Okay, so that's what I have there. In the middle, 2 times x is again 2x. 2 times 2 is going to be 4. So those are the terms I get from multiplying the first two things. I bring down my x minus 4. Let's combine some like terms. F of x equals x squared plus 4x plus 4. All of that is going to be multiplying to x minus 4. So from here, I still have to multiply some more. And I'm going to use this space above, just because I'm running out of space at the bottom. And the bottom is where I'm going to write my final answer. So here we go. X to the third times x. I'm going to write it right here. X squared times x is x to the third. X squared times negative 4 is going to be negative 4x squared. See how I'm just kind of writing those right there. 4x times x is going to be 4x squared, and a positive one that is. And then what I'm going to do is, what I'm going to show you is I'm going to line it up right here underneath this term, because later I'm just going to add it from top to bottom. 4x times negative 4 is going to give me a minus 16x. I have one more term, okay? 4 times x is a positive 4x, and I'm just going to line it up under this common term. What I'm looking for is I'm looking for a common term, so I can just line it up underneath. 4 times minus 4 is going to be a minus 16. So here's what I have. Because I have all the terms all lined up, it's easy for me to add. This one doesn't have another like term, so I'm just going to write it right there. These two cancel, so look how nicely that is. Negative 16x and a positive 4x can be negative 12x, and bring down my 16. So my final answer, which I'm going to write in the bottom, okay, it's positive x to the third minus 12x and a minus 16. And my voice is I'm really losing it now, huh? Okay, I'm going to leave that up there for a second so you guys can finish copying. So let me flip over and show you what you're going to do next, okay? This is where we're going to end our video after you guys do this on your own. I want you to write an equation, a polynomial equation with the zeros of -2 multiplicity once and a 0 of 1 multiplicity of twice, 2 times, and the degree of 3. So go ahead and do this on your own, and when I see you guys in class, I will check all of those. This is the end. Have a wonderful day, and I'm going to see you guys soon.